Okay, you guys, so today we will be talking about increasing and decreasing functions and the first derivative test. So now, just a side note, this comes straight from you guys' lessons. In preparation for the AP exam, your final answer should be stated in a complete sentence and include correct mathematical notation. Avoid using pronouns and refer to functions and variables as they were defined in the problem, such as f of x, g of x, v of t, etc. It is also important to show necessary steps leading up to your conclusion, such as your derivatives, critical values, etc. And I've noticed on your guys' work that you've been doing that, but we need to make sure they're complete sentences. You've been showing the work, but I haven't seen the complete sentences, so let's start tying that together. Okay. All right, so now this one, we're going to actually use an example. Let's take f of x equals 3x to the third. No, let's go. Yeah, let's go. X to the third plus x squared minus 5x minus 5. Alright, so here's the actual thing. So, what the increasing and decreasing functions that you've learned in the book in the first derivative test is, what we're going to be doing is, instead of, we'll be still doing the whole derivative, okay, and this should equal 3x squared plus 2x minus 5. Okay, we'll still be doing that. We'll still be finding the derivative. Except this time we'll be setting this equal to 0 and solving for x. Okay, so this one's going to be a very interesting one in which we do it. Alright, we're going to use the fundamental theorem of algebra, and we're going to factor this bad boy. So we're going to have 3x plus 5 times x minus 1. Okay, and we're going to find that x is equal to negative 5/3 and 1. Okay, so now that we have those points, now what that means is that we're going to use the interval that's what happens when you try and copy and paste. Okay, so negative. Let's go 2, 3, 6. Negative infinity, comma, negative 5/3. And if you notice, I'm going to keep this on an open interval. Negative 5/3, comma, 1. Parentheses 1 comma infinity. So we're going to use it on this interval. So what we're going to do is we're going to test a point in this interval and in this interval and this interval and actually see if it works. And we're going to not test it in the original function. We're going to test it right here in the actual derivative. And if we get a positive value, alright, if we get a positive value, it is increasing in that interval, and if we get a negative value, it is decreasing in that interval. Okay? So it should be pretty simple. Now, we're not going to include these endpoints, because if you include the endpoints, you're going to get 0. It's as simple as that. So, let's say we just plug in negative 3. Let's plug in 0, make our job a lot easier, and let's plug in 4. Okay. So, we plug everything in. F prime of x. Oh, sorry. Negative 3. Is equal to 27 minus 6 is 21. Is that 16? So this turns into 16. So it is increasing on this interval. Okay, simple as that. Next we plug in 0, f prime of 0. Okay, so we plug in 0, we should get -5, so that means it's decreasing here. Okay, so that's pretty cool. And then f prime of, screw it, let's just do 2. Well, let's do 4. Why not? Doesn't matter. Okay, so we plug in 4. All right, and 4 is going to be 16, 48, 56, 53. So that's going to turn into 53. Okay, which makes that increasing on this interval. Okay, now the cool thing is that I know what is going on, but I also know what's happening with the first derivative, how it's looking, all that stuff. Now, if I were to actually graph this, let's go to Desmos. Let's get rid of the last graph that we just did. Okay, if I graph the first one, y equals x cubed plus x squared minus 5x minus 5. Okay, so that's my first actual function. Okay, and let me get rid of steps of 1. There we go. Okay, so there's the steps of 1. Now, if I graph the actual derivative, y equals 3x squared plus 2x minus 5. Okay, if you notice, that matches. Up here it's positive, so that means it's decreasing. It's increasing until it gets to this point on the actual function. So here, let me get rid of this. So it's increasing. The actual function is increasing until it gets to this point, which is the -5 1/3, or -5/3, and then it's decreasing, decreasing, decreasing. It's negative, 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 and then all of a sudden it goes positive again at 1, and it starts increasing. Okay, so if we overlap the two, and this is going to be a preview of what we're going to be getting into, which is the concavity and the second derivative test, okay, which is just taking a look at it. If you notice the original function, it's increasing until it gets to, guess what number? It's the same number. Look at that, that's crazy. Okay, and then it's going to start decreasing, so this function is going to decrease, 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 slow down, and then all of a sudden at this number, oh my goodness, how does that look familiar? Well, it's the same as the first derivative test point that we got. Okay, so it's decreasing until it gets to 1, and then it's increasing the rest of the time. Now the speed is what we'll talk about with the second derivative test, but right now this is pretty awesome, and how you can actually look at the derivative and see what it's telling you a story about the actual graph. Alright, I've already talked about this in the live lesson, but this is really, really, really cool stuff. Okay, so once again, these are points, extrema points. These are absolute maxes and mins. They happen to line up with when a function stops increasing and goes to decreasing, or when a function goes from decreasing to increasing. So that's some actually really cool stuff that you can actually remember from this, okay? Alright, but remember, use complete sentences and just be careful about how you do this stuff, okay? Thank you very much and have a great day.